All right, quiz 4 review. This quiz, it was over exponentials and recursion. This is what the quiz looked like, and let's get started. Number 1 says solve for x. We have 2 to the 5x is equal to 4x, 4 to the x plus 6. So over here, this is actually on the last quiz, so I'm just going to run through it really quick. If you want to go slower, you can look at the last quiz. But this right here, we want the bases to match. We're using the property that says, let's pretend this was 2 to the x is equal to 2 to the 3 power. This implies that x is equal to 3, right? Because everything matches. That means that the bases have to match. They don't match right now, but we can make it match because 4 is actually 2 squared. So this is going to be 4 to the x plus 6 is equal to 2 to the 5x. So now that the bases match, that means that this is equal to that. These two exponents actually end up multiplying. We're going to distribute. So my new problem is going to be 5 times x is equal to 2x plus 2 times 6 is 12. If I bring the 2x over, that's going to be 5 minus 2x, which is 3x. Bring the 12 down, divide both sides by 3, x is equal to 4. Okay, let's look at the next one. Number 2, again, this is on the last quiz. So you have inherited land that was purchased for $30,000 in 1970. The value of the land increased by 4% per year. Create a recursive model. So our recursive model is going to look exactly the same. The only thing that changes is going to be the k. So the model is what we use before we plug in any values. So the model, again, is just going to have the k filled in. Right here it says 4% per year, which means that this is 0.04. My model would be a sub n is equal to a sub n minus 1 plus 0.04 times a sub n minus 1. If you want to know exactly what each of these terms is, go to the last quiz and check that. And I believe I asked you to find ace of 1. So how does that work? Ace of 1, well, the way recursion works. So let me just square this because this is our model right here. This is part of the answer. If I want to find ace 1, I have to find a of 0. A of 0 is the initial value. The initial value here is 30,000. If I want to find a1, this tells me to go to the previous value, which is 30,000, plus 0.04 times 30,000. So how much would that be? 30,000. So you see this was from the last quiz. So 30,000 plus 0.04 times 30,000. It is 31,200. So this is 31,200. What if it asked me to find A2? A2, well, how does the model work? It says go to the previous one, which is what? 31,200 plus 0.04 times 31,200. So how would this look like? This will look like 3,200 times, you see how this answer just means they use that value, times 0.04. So I'm doing this part first, plus 31,200. A2 would be 32,448. This is $32,448. That's how much it would be worth after 2 years. And you could keep it going. Again, recursion, all that means is that it repeats itself. You have to go back to the last one in order to keep going. What about number 3? Number 3 says graph y is equal to log base 4 to the x. The way I like to explain this one is that log is what? Log is actually the inverse of exponentials. So I'm going to compare it to the exponential y is equal to 4 to the x. I'm going to graph this one because this is pretty straightforward how we graph this one. And then after we graph that, we're going to use that information and graph y is equal to log base 4 to the x. After I do that, we can double check on the calculator. So y to the 4, if y is equal to 4 to the x, the way we usually do this by hand is we use these anchor points. We use the anchor points 0 and 1. So 0, if I plug in a 0, anything to the 0 power is going to be 1. So it's going to be 0, 1 right here. If I plug in a 1, all it's going to give me is the base itself, 1 base. So this is going to be what? 4. At 1 is going to be 4. At -1, what is it going to do to the base? It's going to flip it. So this is going to be 1/4. 1/4 is somewhere over here. So this is my exponential 4 to the x. Okay. And this is what? This is the asymptote right here. Let me draw that a little bit better. This is the asymptote right here. Now, log base 4 to the x, we have shown in class that this is the inverse of that. We've proven that in class. And what does inverse mean? Inverse means that the x and the y flip sides. So instead of 0, 1, it's going to go through 1, 0. So it's going to go through here. Instead of 1b, is going to go through base 1. Right here, the base is 4, so it's going to go through 4, 1. And instead of -1 and 1 over, this should have been base right here. 1 over the base is going to be 1 over the base and -1. So 1/4 and -1 was right here. So it's going to look something like that. And then if you notice, my asymptote now is over here. And another important fact is that since these two are inverses, what do we know about the graphs of the inverses? They are reflections of each other, right? Reflections over what? Is not over the x-axis, right? It's not over the y-axis, it's actually over this line. This line is called y equals x. Y equals x. This line is y equals x. And inverses are reflected over that line. Let's look at the next problem. Number 4, find the inverse of y is equal to 5 to the x over 4. So the inverse here, we have an exponential. We're trying to show you that what we're trying to prove here is that the inverse is going to end up being a logarithmic equation, a logarithmic function. So let's find the inverse. What does inverse mean? Inverse means whenever I get the x and a y and they switch position. So this is going to be x is equal to 5 to the y over 4. Now this is already the inverse right here. But if we want to have the inverse function, it has to say y is equal to something. Okay? It has to say y equals. We have to solve for y. So what we're going to do is, in order to separate the y from the 5, since it's in the exponents slot, we're going to use logs. We're going to actually rewrite it in logarithmic form. So the way we write this as a log, this is going to be log of whatever the base is. Here the base is 5. After the base comes the result. Right here the result is x. And then after that the exponent goes at the end. This is y over 4. If you forgot how to do this, this is how it goes. If you have base to the exponent is equal to a result, you can rewrite this as a log like this. This is the same thing as log of the base goes right here. The result goes right after that. And this is equal to the exponent. So that's what we did here. But now we have y over 4. Again, we want y by itself. How do I get rid of this 4? Just multiply both sides by 4. So now you're going to end up with y is equal to 4 times the log base 5 of x. Base 5 of x. And again, this is the inverse of that. These two are the opposite to each other. And it's good to notice that this is an exponential function. This is a logarithmic function. They are inverses of each other. Okay, let's look at number 5. Rewrite the exponential as a log or vice versa. So we're going to use that same rule from number 4. We're just going to rewrite it. Oh, let's go back. We're just going to rewrite it. This is an exponential, so we're going to just write it as a log just to know we know the definitions and how to rearrange it. So this is log. After log, right here's the base. The base here is m. After the base goes here, what comes next? The result. The result here is 22. And at the end, this is equal to whatever the exponent is. Whatever in the exponent slot goes right here. So this and this are equivalent to each other. They're the same thing. That they contain the same information, but one is in exponential form. This one is in logarithmic form. This one, I'm going to do it the other way. Again, we just want to show that we know how to convert from logarithmic to exponential and back. So this is logarithmic right now. We're going to write it as an exponential. So right here, where's the base? This is the base. 2 to the what power? The exponent is here. 2 to the x is equal to this is actually the result. So this is how you write this logarithmic, can be rearranged as that. And these two, again, contain the same information. They're equivalent to each other. All right, let's do the last one. Number 6, it says, if I change the graph of 3 to y is equal to log base 4 of x plus 2, describe the transformation. Identify the domain and range. Okay, so the graph from number 3 was actually y is equal to log base 4 of x. And I actually forgot to graph this on a calculator. This is how you do it. There is no button that says log base 4. The log in your calculator, this log has an imaginary base 10, okay? Because it's a special number, it gets a special button. This log has a base 10. I don't have a base 4 log. So we can actually rewrite this as, we can change the base. We can rewrite this as log of x over log of 4. That is log base 4 of x. So let's look how that one looks like. And we're going to use that so we can rewrite, so we can write this one and see where it goes. So we're going to do here, we're going to do, let's go back over here, log of x divided by log of 4. This is log base 4 of x. So that's that one. Let's rewrite this one. Let's do this one and see where it went. It only has one number different. So this is actually going to be what? This is actually going to be log of x plus 2, whatever the result part is right here, x plus 2 over log of 4. And this log of 4, all it does is it changes the base to 4, right? So once we come over here, this is going to be log of x plus 2 divided by log of 4. And we see that this went to the left by how many? It went to the left by 2. And one thing I want to point out is right here, this calculator shows that this ends right here. This logarithmic function does not end. It keeps going. The only thing is what? That there's an asymptote right here, so the calculator does not draw it for whatever reason. Okay, so what happened between the original one and the left and the next one? It actually went to the left by 2. Okay, it went to the left by 2. The domain and range, let's look at the calculator. The domain is going to be all the numbers from here to the right, right, is all the x contained. So this we write x is greater than -2, because that's where my asymptote is now. At -2, the function is to the right of that. The range is going to be all the y's. So this function is going to go down forever and is actually going to go up forever. So this is all reals. Okay. And one last thing I want to point out about this one is, let's say that was another number, log of x plus 2 plus 3. This number right here moves it left and right. This number moves it up and down. So this moves it, is opposite to intuition, is opposite to what you think it should do. This plus 2 actually moves it to the left. If it was a plus 3 right here, it would move it up. But since it's not here, you don't have to worry about that. But it's just something I want you to take a look at. Okay, so that is all for this quiz. Thanks for watching.